Hello, this is Mrs. Doro, and we are going to look at writing formulas from names of binary ionic compounds. Now that you know how to write the names, we're going to look at how to write the actual formulas. When I say writing the formulas, when you see something that maybe looks like that, and you're not sure, but those symbols look familiar, but you have no idea how they got the numbers, that's what we're going to talk about today. Okay, so the first question is, why is it written the way it's written? Why NaCl in this particular case? That's table salt. Why not put the Cl first and then the Na? Or why don't you have a 2? Why do you have a 2 in this one and not in the one above it? There's no 2 there. So there's some steps or rules to follow, but the overall goal is to balance the number of positive ions with the number of negative so that you have a 0 charge. Remember, we want to have a 0 charge. That's going to make everybody happy when they don't have a charge. Rule number 1, always write the positive ion first. That's the cation. So you have to look on your periodic table and you have to find if it's sulfur or magnesium, which one is positive. Well, on your periodic table, magnesium is actually on the left-hand side. So we're going to write that one first. All right, because it is positive, and then sulfur is a negative, so it's going to go next. The positive ion goes first, the negative goes next. All right, now we know that the cation, or the positive ion, is going to go first. So we can see magnesium is a positive 2, so we're going to write Mg. But next thing I want you to do is I want you to write its charge, plus 2, right by it. All right, then we're going to write sulfur. We're going to go over to the right. We're going to find S, and it is a negative 2. So now I've got my symbols, and I've got my charges. Rule number 3 is if the charges are equal, then they're going to cancel out. And I have a positive 2 for magnesium and a negative 2 for sulfur. So if I put Mg and S together, that plus 2 and that minus 2 cancel each other out, so I don't even need to write them. I'm just going to write magnesium sulfur. What I'm trying to do is I'm trying to reduce it down, but I'm not going to write ones. I'm not going to put a 1 and a 1 here. 1 is redundant. If we didn't have a magnesium, if we didn't at least have 1, we wouldn't write Mg. So we're never going to write ones. We're just going to write MgS, so if they cancel, no matter what the charge, whether it's plus 1, minus 1, and they're the same, or plus 3, minus 3, if they're the same ones, they cancel, and you just rewrite the symbols plain, all by themselves. All right, rule number 4. What happens if the charges do not cancel? So you have to figure this out. So first I've got aluminum has a plus 3, and fluorine is a negative 1, and those don't cancel. So it says to add another ion of the same kind until they cancel. And you're always looking for the smallest whole number ratio. So it's going to take me 3 aluminums right there, plus 3. But I only have 1 fluorine. So really, to get these to cancel, it's going to take another 2 fluorines. I'm going to have a total of 1, 2, 3 negative 1 charges. So now I have positive 3, and I have a total, if I add those all together, negative 3. So actually, I'm going to cancel. If I have Al, if I have 1 of those, how many fluorines do I have? I have 3. So I'm actually going to write not its charge, because its charge is negative 1, but I'm going to write how many fluorines I have. And you might not want to do this, but I always want you to write out the symbols with the charges and show the math of how you got that, because we want the overall charge to be 0. So now, if you look at it mathematically, I have plus 3 for aluminum, and because I have a negative 1, but I have 3 of them, it's actually going to give me a negative 3 charge. So I have plus 3 and negative 3, they cancel out. My symbols together make a compound of AlF3. That's aluminum fluoride. Okay, now I have some practice problems for you to try. So you're going to write out the symbols, check their charges, show the math, everything that you need to do. So take a minute right now, pause this, and do these out. Okay, so now let's take a look at some of these answers. Calcium chloride has Ca and Cl. If you look at the Ca, it has a +2 charge. Chlorine has a -1. So really it's going to take 2 chlorines mathematically to equal 1 calcium. Alright, so I have 2 -1 charges for -2 total, and +2 charges. So I rewrite it, Ca, and I have Cl2. Sodium and phosphide, I have sodium, which has a +1 charge, and phosphorus, or phosphide, has a -3 charge. So because sodium only has a +1 charge, it's going to take 3 of those to equal 1 phosphorus. So I've got Na3P. Titanium oxide. Titanium is a transition metal. It's got a +2 charge, and oxide is a -2. And those cancel. +2, -2. So we're just going to rewrite it, and we're going to write it TiO. Now I want you to take a look at magnesium nitride. Magnesium is a +2 charge, and nitride is a -3. So here's the problem. If I just add another magnesium, I'm going to have a 4. If I just add another nitrogen, I'm going to have a 6. So I need to find a common denominator. The lowest common denominator that both 2 and 3 go into is 6. So if I add another magnesium and another magnesium, that gives me 2, 4, 6. Now if I add another nitrogen, that gives me 6. So I now have +6 and -6. So now I have a cancellation. So I'm going to write Mg, and there's 3 of them, and I'm going to write N, and I see 2. So Mg3N2. That was probably the hardest one on this page. Good job if you got it.